All right, hey guys. My name's Logan, and I'm doing the genetic engineering of biofuel. The global attention of biofuels has grown in recent years due to the acknowledgement of fossil fuels being finite, as well as their negative effect on the environment from their utilization. From this, many countries worldwide have been experimenting with using biofuels as their source of fuel for transportation. Biofuels ultimately are useful to humans to eliminate greenhouse gas emissions and establish an energy source that is not finite. Ethanol is the most widespread form of biofuel, which is a clear alcohol made from a variety of biomass materials, which are renewable organic resources. Most commonly used in Brazil, generic ethanol has been used as renewable energy for transportation. Cellulosic ethanol, however, has the largest potential for widespread use as a biofuel due to its abundance in grass, wood, and other crops. Cellulosic ethanol is engineered through breaking down the cellulose of the biomass, which involves manipulating the biosynthetic pathway to weaken the cell wall for utilization. The main issue with cellulosic ethanol is that the energy needed to make the cellulosic ethanol exceeds the energy produced, creating a negative net gain of energy. Biodiesel is a chemical reaction of vegetable oil and ethanol into biodiesel in a process known as transesterification. Biodiesel's compound has hydrocarbons just like normal diesel, meaning it can be used in traditional engines automatically. The main issue with biodiesel, however, is that the reaction could contain unconverted vegetable oil, which is an incomplete reaction and cannot be fully used as energy. Still, the United States leads in the world in production and consumption of biodiesel at approximately 2.2 million gallons annually, mostly in trucks in California due to state environmental legislation. Biobutanol is a very efficient biofuel with an energy content close to gasoline, the most of any other biofuel. It is engineered in a very similar process as traditional ethanol, which includes corn feedstock being grinded into flour to ferment into biobutanol in a process called dry milling. The issue of biobutanol is the low production rate despite having the highest energy content, as it yields 10 to 30 times less than ethanol due to its fermentation process. Despite this, biobutanol is used in combustion engines of vehicles and mixture of gasoline, mainly in the US and UK. Biogas is a biofuel produced from the decomposition of biomass, composed mainly of methane and carbon dioxide. The decomposition includes anaerobic bacteria breaking down the biomass to produce biogas, which occurs in solids, water bodies, and waste landfills or engineered in a controlled lab, where scientists are engineering synthetic microbial communities to make anaerobic digestion faster. The main issue with biogas is that there are no technological advancements yet to make this a viable biofuel to use commonly. Despite this, biogas is commonly used to produce electricity in combustion engines, where it's mostly used and developed in Germany. As a future outlook, the growing pressure to reduce greenhouse gases in the world's environment has led to advanced research for the diverse types of biofuels. As technology advances to make biofuel development more efficient, the future of the world will grow to a great amount of renewable biofuels and keeping the environment green. And those are my sources. Thank you.